So doubly reinforced means from code book IS 456 we have certain procedure. In IS 456 page number 96 we have the formula for calculating the compression zone reinforcement. So the formula which we see is mu minus mu limit will be equal to FSC ASC D minus D dash. Here D dash is nothing but the top cover. So in order to calculate FSC value, we have the formula, that is by relating the strain with the stress of the concrete. So the strain value is 0.0035 XU max minus D dash divided by XU max. So XU max value you can find it from page number 70, that is they have given the value as XU max by D equal to 0.48 based on the grade of steel. So for Fe415 the value is 0.48. So I can say that XU max equal to 0.48 D. So here the D value is 325. So the XU max value is 0.48 into 325. So the value is 156 mm. So here problem they have given it as proportional to, that is the stress is proportional to this value. So here we have introduced equal to, so we need to multiply it with Young's modulus of steel. So the value is 0.0035 into 156 minus D dash, the cover is 25 mm, divided by 156 into 2 into 10 to the power 5. So here the answer which we are getting is 587.82 Newton per mm square. So we have calculated the FSC value. So we know the mu limit value, FSC value, D dash and D dash value. So we can calculate the ASC value. So here mu limit is, mu is 335.73 minus mu limit is 85.46 into 10 to the power 6, because here the value of ASC we will calculate in terms of mm square. So I am converting everything into Newton mm. So here FSC values in terms of Newton per mm square. So we can directly take it as 587.82 into ASC into D is 325 and D dash is 25 mm. So the ASC value which we are getting is 1419.2 mm square. So this is our area of reinforcement which we need to be provided in the compression zone. So next I need to calculate the number of bars for the compression zone. You know the formula, total area divided by area of 1 bar. So here I am going to assume or use 20 mm dia bar. So number of bars required is, total area which I have calculated is 1419.2 divided by pi into 20 square divided by 4. So therefore the number of bars required is, so the value which I am getting is 4.51. So we can round it off to 5 numbers. So here provide 5 number of 20 mm dia bar. So next I need to calculate the tension zone reinforcement. The formula to calculate tension zone reinforcement is AST equal to AST1 plus AST2. So AST2 can be calculated by using the formula FSC ASC divided by 0.87 Fi. It is nothing but we are equating the steel which is equal to the concrete. So here FSC value which we have calculated is, here if you see we have calculated FSC value is 587.82 and ASC value is 1419.2. So I am going to substitute this value here. So 587.82 into 1419.2 divided by 0.87 into 415. So the AST2 value which I am getting is, so 2310.58 mm square. This is due to AST2. So next, in order to calculate AST1, we can use the formula mu limit, because it is a doubly reinforced beam. So here we need to use the mu limit. The formula is 0.87 Fy AST d into 1 minus Fy AST divided by FCKBD. So this formula was given in our IS 456 page number 96 under the sections without compression zone reinforcement. So G 1.1b, you have this formula. Here you will have mu in that code book, but here, because in doubly reinforced beam we need to use, instead of mu we need to use mu limit. So here, if you are going to substitute the value, you need to substitute the mu limit value. Mu limit values which we have calculated is 85.458 into 10 to the power 6. Because here if you see, Fy and FCK will be in terms of Newton per mm square. So we need to convert everything into Newton per mm square. So 415 into AST1 into D is 325, 1 minus 415 AST divided by FCK is 20, B is 300 and D is 325. So here the AST value is, so AST value which we are getting is 901.1 mm square, that is AST1 value. So in order to get the AST, we need to add these two values, 901.1 plus 2310.58. So the total value which we are getting is, 3211.58 mm square. So here I am going to use 25 mm dia bar, and I need to calculate the number of bars, 6.54. So I can take it as 7 numbers. So here write, provide 7 number of 25 mm dia bar. If you want, you can write as tension zone reinforcement. Here you can write provide 5 number of 20 mm dia bar as compression zone reinforcement. So next step is we need to check this for the shear. Here Vu value which we have calculated already is 196.76 kilonewton. So the first step is we need to calculate the nominal shear. The first step is we need to calculate the nominal shear stress tau V equal to Vu divided by Bd. So this formula is given in your IS 456 page number 72. So here Vu is 196.76 into 10 to the power 3 divided by B is 300 and D is 325. So the value which we are getting is 2.0 Newton per mm square. So next step is we need to calculate the percentage of reinforcement, that is how much amount of reinforcement we have provided in the tension zone. Here the percentage of reinforcement, if you see, we are providing 7 number of 25 mm dia bar. So what I am going to 7 into pi into 25 square divided by 4 will give the divided by BD into 100. So this formula is given in our IS 456 page number 73. So here the value will be, which we are getting is 3.5 percentage. So from page number 73 of IS 456. So here if you see, in IS 456 table 19 we have the percentage of reinforcement, that is AS divided BD into 100, which we have calculated, and they have given the values. So based on this value, we need to, by considering the grade of concrete, we can calculate the design shear strength, that is design shear strength of concrete. So design shear strength of concrete tau C equal to, here if you see, we have calculated the percentage of reinforcement as 3.5 percentage. Here if you see, if it is above 3 and above, then we need to take this value. So I am using M20 grade of concrete. So for that 3 and above, the value is 0.82 Newton per mm square. So here if you see, tau V is greater than tau C, because the shear stress which is created due to the load is 2 Newton per mm square, but the concrete strength, that is the design shear strength of concrete, is 0.82. So here it is unsafe, so we need to provide shear reinforced. So in order to provide the shear reinforcement, we need to follow this concept. Shear reinforcement shall be provided to carry a shear equal to, that is nothing but balance shear VUS, which will be equal to VU minus tau C into BD. So VU, which we have calculated already, the VU value is 196.76 kilonewton. So 196.76 kilonewton. Here this value in terms of Newton, so I am converting this into Newton. Minus tau C is 0.82, B is 300 and D is 325. So here the answer is 116,810 Newton. I can write it as 116.8 kilonewton. So based on this formula, we are going to calculate the value. So VUS equal to 0.87 Fy ASV D divided by SV. Here if you see, ASV means area of shear reinforcement. So we can assume the shear reinforcement, that is stirrups, which we are going to provide, because shear reinforcement is nothing but your stirrups which you are providing in the beam. So I am going to assume two-legged 8 mm dia stirrups. So two-legged means generally the shear reinforcement, if you are going to provide for the beam, then we will provide like this, right? Stirrups will be provided like this. So here this and this represent the two legs. So ASV equal to pi into 8 square divided by 4 into 2. So the answer which we are getting is 100.53 mm square. So substitute in this. So I need to find out the value of SV. So I am bringing this SV here and VUS is coming here. So 0.87 Fy 415, ASV is 100.53 and D is 325 and VUS is nothing but 116.8 into 10 to the power 3. So the SB value which we are getting, is 101 mm. So we can write it as provide 8 mm, provide two-legged 8 mm dia stirrups at 100 mm center to center spacing. So next step is we need to provide the reinforcement detailing. Here if you see, I have drawn the reinforcement detailing. So I have given the longitudinal section and cross section, and here if you see, we have calculated the tension zone reinforcement as 5 number of 20 mm dia bar and compression zone reinforcement as 5 number of 20 mm dia bar and tension zone reinforcement as 7 number of 25 mm dia bar. So here if you see, I have mentioned the 5 numbers at the top, that is 5 number of 25 mm dia bar, and 7 numbers at the bottom, which is 7 number of 25 mm dia bar, and I have marked the stirrups as two-legged 8 mm dia stirrup at 100 mm center to center spacing, which we have provided. So with this we complete the problem. In addition to this, if they have asked to calculate the development length and deflection, you need to do it as per the IS 456 codebook. Thank you.